Okay. Okay, now we will continue. So as I told you, there are two ways. One is by using um, graphical method, graphical solution method, or graphical solution or graphical method. Okay. And another way is to do it by simplex method. Simplex method. Okay, this method also we are going to study, but later on. Today we will discuss about graphical method. There are two ways again by which graphical method can be used. You need to draw the graph, that no doubt about it, but going towards optimal solution there are two approaches. One is called as extreme point enumeration method. Extreme point enumeration method. Extreme point enumeration method, and another is iso profit line or iso cost line. Iso profit line or iso cost line method. Okay, so extreme point enumeration is one way, and iso profit line in case of maximization problem, and iso cost line in case of minimization problem. So these are the two ways which we can use for solving this problem. So we will go for solving by using one method rather, that is extreme point enumeration method. So this is the problem which we are going to consider for today's lecture. Now how to solve it by using graph. So do you have graph papers? Graph
Yes, sir.
pencil.
Yes, sir.
Now while solving this by using graph, you have to focus on the constraints. Okay. Now how many number of constraints are there in this problem?
3.
3.
Okay, this non-negativity condition we will call it as a condition for the time being instead of calling it as a separate constraint. But this will also serve as a constraint, no doubt about it. Okay. Apart from that, by eliminating non-negativity condition, how many number of constraints are there?
2.
2. Okay. So there is one inequality equation. 2x1 plus 3x2 is less than or equal to 60. Now what you have to do is you have to consider it as an equality equation. So all the whatever constraints are there, consider them as equality equations, or rather convert them into equations, and then draw the graph. Okay. Now there are two variables are unknown, x1 and x2. Okay, 2x1 plus 3x2 is equal to 60. So you have to consider that 2x1 plus 3x2 is equal to 60. So this is the equation of a line. Do you agree with it? Agree with me? 2x1 plus 3x2 is equal to 60 is a 2D plot, and 2D line is possible. So you have to draw it. How you will draw it? First of all, you have to consider. Okay, let me write these two equations again. Okay, what is first equation? 2x1 सांगा मला.
2x2.
2x1 plus
3x2.
3x2. Now you have to convert it into equality is equal to 60. So this is one equation. Now if you consider drawing graph for this equation, put x2 is equal to 0 first and find out the value of x1. So how much will be the x1 if x2 is equal to 0? Is it 30?
Yes, sir.
Okay. Then put x1 is equal to 0 and find out x2. Is it 20?
Yes, sir.
Okay. So 20 will be there. Now you can consider x1 on one axis, x2 on another axis. Consider a point 20 and 30 on these two ordinates or axis and ordinate, and you can draw a line. Do you agree with me?
Yes, sir.
Okay. Similarly, what is the next constraint? दूसरा constraint what है 96 वाले?
4x1 plus 3x2 equal to 96.
4x1 plus 3x2 equal to 96. Okay, this we have converted into equation. Now here also put x2 is equal to 0. Then what will be the value of x1? Is it 24?
Yes, sir.
Okay, then put x2 is equal to 0 and find out, put x1 is equal to 0 and find out x2. How much is it?
32.
32.
32. Okay. So now on one axis there will be x1, on another axis there is x2. You can draw by taking x1 24 and x2 32 and one line. Is it possible? Yes or no?
Yes, sir.
Yes. Now we are having another condition, that is x1 x2 greater than or equal to 0. In which quadrant x1 x2 is greater than or equal to 0?
First.
First.
Is it first? Is it
Yes,
first?
sir.
Yes. Okay. So in first quadrant our lines will be there, and in first quadrant our feasible region will be there. What is feasible region? I will tell you. Okay. So do you agree with this? By considering non-negativity condition and these two constraints, we are drawing the lines in first quadrant, and we will consider the region in first quadrant only. Is it okay? Okay. Now draw these two lines by using your graph. Take a suitable scale. एका ग्राफ पेपरवर तुम्ही 2 किंवा 3 सुद्धा ग्राफ काढू शकताय. जर स्केल कमी असेल तर तेवढंच पोर्शन यूज करा ग्राफचा, किंवा 2-2 काढा. एका ग्राफवर 2चा स्पेस यूज करा. सो यू मेक स्केलिंग अकॉर्डिंगली. थोडं व्यवस्थित स्केल येईल कारण पॉइंट्स आपल्याला घ्यायचे, त्यामुळं पॉइंट प्लॉट करता आले पाहिजेत ग्राफवरून. असं स्केल घ्या. ठीक आहे. अँड देन ड्रॉ दिस टू लाईन्स ऑन द ग्राफ पेपर. काढता येतील का?
हो सर.
ओके, काढा. झालं का सगळ्यांचं? यू ड्रॉ दिस टू लाईन्स ऑन ग्राफ पेपर बाय taking abscissa and ordinate. Okay, and then draw these two lines. Take a suitable scale for that purpose. Now maximum x2 is 32, maximum x1 is 30. So you can take a suitable scale and draw it. On one graph paper, you make a provision of completing two problems. First, upper half and lower half portion. केलं काय एवढं?
Yes, sir.
झालं सगळ्यांचं?
हो सर.
Okay. So now we are going for solution. Now this is the line 2x1 plus 3x2 is equal to 60. 20, 30. Okay. So on this x2 is taken. On this horizontal axis x1 is taken. Vertical axis x2 is taken. So it is divided like this. Then 30, 20 line. That is 2x1 plus this line. Let me this line. Okay. 2x1 plus 3x2 is equal to 60. तुमचे पण असंच आले का?
हो सर.
Okay. Then another line is 4x1 plus 3x2 is equal to 96. This line. Okay. Now is there any other constraint? No, these are the two constraints and non-negativity condition. So we have taken the first quadrant into consideration. Is it okay? इथपर्यंत लक्षात आलंय सगळ्यांच्या?
Yes, sir.
ठीक आहे. Okay. Now you see that for this is a case of what maximization or minimization.
Maximization.
Maximization. And what are the original constraints, whether they are less than or equal to or greater than or equal
Less than.
to? Less than or equal to. Okay. So this constraint is less than or equal to 60. Means it must be either equal to 60 or less than that. So any point if you take below this, in this direction, towards 0, from this particular line, will go towards 60 or less than 60. Am I right?
Yes, sir.
Okay, 60 or what is this? For this particular problem, okay, towards this, from this line, from this line. Okay, so we have to select the area in this direction towards 0, 0. This is 0, 0 point. Okay, towards 0, 0. Similarly, the second constraint is also less than or equal to type. So you have to observe towards 0, 0 from this line. Is it okay? Is it okay?
Okay, sir.
Okay. Now you have to see that by all these lines, whatever points are there on x1, x2 as well as in between the region, in between the region. Okay. So if you see this entire this much thing, okay, you can observe that let me select the color. I don't know how to go for it. Okay, ठीक है. So we are observing in this direction. Now, if you see the points which are close to 0, 0, 0, 0, 0, that need to be considered. Amongst all these points made by these constraints or these constraint lines. Okay, so you see here there is a point P. This one. This one is point P. Okay, so point J is away than point P. So you have to consider this. Then you go towards right and observe that any other point on the line is there, which is also towards 0, 0, and there is no other point near that. Say this one. This one, Q. Okay. Again, when you are going towards right, you can see that this is the point R. Okay. So P, Q, R, and this is the point O. Is it okay? So area or region bounded by OPQR is a feasible region. Okay. If you choose any point from this region, that will satisfy all these constraints, including the non-negativity condition. Do you agree with me?
Yes, sir.
Okay. So whatever this region is there, how to select the color? Do you know from these comments? Different color. Hmm. How to use different color? It is having default color. Okay, so whatever it may be, this region, I don't know what is happening. This much region, This region is nothing but the feasible region. Okay, I will erase all this. हे सगळं एकदम कसं इरेज होईल? How to do that? I don't know. In PDF, this how to use these properties, but let me erase it first. Okay, so again I will draw it. This much region, whatever is there. प्रत्येक वेळा सिलेक्ट करायला लागतं. This much region is feasible region. Are you getting this? No, this will not be there. This will not be there. Okay, so whatever shaded area is there, this is feasible region. Okay, bounded by OPQR. Bounded by OPQR. Is it okay?
Yes, sir.
Okay, sir.
इथपर्यंत सगळ्यांच्या लक्षात येते. ओके, ठीक आहे. So we are going to use extreme point enumeration method. Now this region is having 4 extreme points. One is O, another is P, one more is Q, and another is R. Now we have to find out the coordinates of these extreme points, put those coordinates into objective function, find out the value of the objective function for all these 4 points, and select the maximum objective function coordinate as the optimum solution. That is the process. Okay, can you do that? Okay, I'll write it in one note. इथं कसं लिहायचं माझ्या काय लक्षात येत नाही. It's a drawing tool, but how to write? Okay, I will write it here. In one note, I'll write it here. Okay, what is the first point? O. What is the first point? O. That is 0, 0. 0, 0. Now tell me, if you put it in objective function, what will be the value of Z? What is our objective function?
40x1 plus 35x2 maximizing
40x1. So 40 into 0 plus 35 into 0 is equal to 0. So for point O, it is 0. Now tell me, for point P, what are the coordinates?
0, 18.
0,
18.
18 or 20?
18.
20.
0, 20. Okay, so 0, 20. which implies Z is equal to 40 into 0 plus 20 into 35. How much is it? Sanga?
700.
700. Okay. Next case. What is the point Q? What are the coordinates for this? For Q, आता तुम्ही ग्राफ काढला तुम्हाला माहित आहेत coordinates.
18, 8.
18,8. Okay, so 18,8, which implies Z is equal to 40 into 18 plus 35 into 8. How much is it?
1000.
1000. Okay, next. PQR. What is R? R is
24,
34.
24, 0. Is it 24? 24, 0. Which implies Z is equal to how much?
960.
960. This 1000 is okay, no? बरोबर आहे ना? 1000 value बरोबर आहे का?
Yes,
40
sir.
into 18, okay. Now tell me which particular point is giving you the maximum value of Z?
हो सर बरोबर आहे.
Which particular point is giving you maximum value of Z?
Sir, point
Q.
Q, 18,8. Okay. So what is our solution? Our solution is Z max is equal to 1000, and for that X1 means 18 number of products of A should be produced and 8 number of products of B should be produced, so that we will get maximum profit, that is 1000 in terms of rupees or order it maybe. Got it? So what is our solution? Solution is X1 is equal to 18, X2 is equal to 8, and Z max is equal to 1000. So this particular point is giving you the optimum solution. This particular. Is it okay? ठीक है?
Yes, sir.
Okay. So this way we are getting the solution. म्हणजे काय तर या पर्टिक्युलर ऑब्जेक्टिव्ह फंक्शन साठी for this particular objective function and whatever constraints are given to us, within which this is the optimum solution for this problem. That means x1 is equal to 18, x2 is equal to 8, and z max is equal to 1000. Are you getting me? So here we have used extreme point enumeration method. Means what? We have completed the graph by considering all the constraints, and then we identified the feasible region within which the solution is available, and then choose all the extreme points of this particular feasible region, find out the coordinates of all these extreme points, put those coordinate values into the objective function, find out the objective function value, consider the maximum objective function value, and corresponding to that whatever point is there, that is nothing but your solution. Is it okay? Is it okay? Now see, this
Okay,
much OPQR is your feasible region. If you choose any point from this region, it will give you the feasible solution. Feasible means it will satisfy all the constraints. Okay, you take any point from this feasible region. Even if you take any point from point P to Q on that line, that will also satisfy all the constraints. Similarly, from Q to R line, that will also satisfy all the constraints. That means from O, P, Q, R, whatever points if you consider, they will satisfy all the constraints, and that will give you solution to this problem, and that solution will be a feasible solution. Okay, but though it is feasible solution, it is not optimal. The optimal solution is only at point Q, and which is having value x1 is equal to 18 and x2 is equal to 8. That is the only optimal point. All others are, though they are giving solution, they are giving feasible solutions, but not the optimal solution. Do you agree with me?
Yes, sir.
ठीक है. Now can you draw another graph? हा ग्राफ कंप्लीट केला सगळ्यांनी. ते पॉइंट सगळे लिहिले का? ओ पी क्यू आर, त्याचे कोऑर्डिनेट्स, झेडच्या व्हॅल्यूज आणि सोल्युशन व्हॅल्यू लिहिले का?
हो सर.
ओके, नाउ वी विल गो फॉर
पॉइंट ठीक आहेत.
येस. पॉइंट सी एंड डी एक एक्झाम्पल म्हणून घेतलाय. फॉर एक्झाम्पल, इफ आय कन्सिडर पॉइंट डी, whether that point will give you the feasible solution?
No.
No. Point C?
No.
Just for telling you, point C and D are shown. That if you consider any point from this region, that will not give you the feasible solution. Okay. आणि लाईन PQR पासून जर तुम्ही पुढे जाल, म्हणजे इफ यू गो फ्रॉम अवे फ्रॉम PQR, away from origin, away from PQR line, you will not get the feasible solution at all. Are you getting? So from PQR towards 0, 0, if you go, you will definitely get the feasible solution, but it may not be the optimal solution. Is it okay?
Okay, sir.
ठीक आहे. अजून कोणाला काय डाऊट आहे का? असेल तर विचारा, नाहीतर we will go to the next problem. Okay, what was our next problem? Okay, now graphical method is having one limitation. What is that limitation?
2D graph.
2 variable.
2D graph, yes. So if at all only two decision variables are there, then and then only we can go for graphical method. If more than two decision variables are there, we can't use graphical method. We have to go for another method, that is simplex method. And simplex method can be used for any number of variables, whether it is 2, 1 or more than 2. But if it is more than 2, only simplex method you have to use. You can't go for graphical method. Is it okay? So this problem we will consider for simplex method later on. Okay, now tell me whether this problem can be solved by graphical method?
Yes, sir.
Yes, okay, then can you solve it? Try to solve this problem by using graphical method. सोडवा. So you need to focus on two constraints, including third non-negativity condition. Then make those constraints as equations. Find out value of x1 by putting x2 is equal to 0 and x2 by putting x1 is equal to 0 in each of these equations, and plot the points and draw the lines. Then focus on the original problem constraint and see that whether less than or equal to sign is there or greater than or equal to sign is there. Based on that, you have to select the feasible region. After selecting the feasible region, you have to consider the extreme points on those feasible region. Put those values of extreme points in objective function, find out the objective function value for all these extreme points, and select that objective function value which is maximum in maximization case, minimum in minimization case, and corresponding point is the optimum solution. Okay? Can you do this? चलेगा? मी लिहायला पाहिजे का x1 x2 च्या व्हॅल्यूज? एनीबडी? रोल नंबर 74. 74 आहे का? 75? रोल नंबर
Hello, sir.
74 आहे ना?
हा आहे सर.
लिहायला पाहिजे का करू शकता तुम्ही?
नाही करता येते सर.
Right. First find out the values, draw the graph, select the feasible region, and then tell me if you done with this. Okay, now check that. The line 20x1 plus 50x2 is having 96 as a coordinate on x2 and 240 as a point on x1 line. Is it okay? Then 80x1 plus 50x2 is line PT. Line KR is first line. Line PT is another line. Okay. Now, what are the types of constraints? Whether they are less than or equal to or greater than or equal?
Greater than equal to.
Greater than equal to. So you have to go away from 0, 0. Okay. Now this is K R line. Okay. And you have to think in this direction. So we are going away from this. So anywhere, wherever you see in this direction. So far this line is concerned. Okay. So feasible region will be in this direction. And then for PT also greater than or equal to type constraint. So again away from this. Are you getting this? Okay. Now you choose those points which are away from 0, 0 and they get cut by all the lines which we have drawn by considering the constraints into account. Okay, so there are two only. There are two only. So we will get P, Q, and R. These are the points, and they will bond the feasible region. So feasible region is here. Anywhere up to infinity. Up to infinity, whatever point you choose, and if you put into objective function, that will satisfy all the constraints. And that is the feasible solution for this problem. Are you getting me? Are you getting me?
Yes, sir.
Okay. Then what we are interested in?
Optimal solution.
What is our objective function?
Minimum cost.
Minimization, yes. Previously it was maximization. So what we had decided, we have started from 0, 0 and we started away from 0, 0, thinking away from 0, 0 or observing away from 0, 0 and found out the point uh, where optimum solution is there. Now minimization is there. So you can come from infinity towards 0, 0 and see the point where minimum solution is possible. Okay, so these are the 3 points which can be considered for extreme point enumeration case. Okay, extreme point enumeration case. Now can you tell me the values of these 3 points? What is P? P point किती येतोय?
0,144.
0,144. What will be the objective function value for this point? Can you tell me? Then there is one more point Q. Tell me the coordinates for this. And then there is another point R. Tell me value for this. Then find out the Z for this. सांगा Q चा पॉइंट किती आहे किंवा आधी Z ची व्हॅल्यू सांगा P पॉइंट साठी
3, 4, 5, 6.
3, 4, 5, 6. Okay. Now tell me the point Q.
41,79.
41,79. सगळ्यांचा आले का असंच का कुणाचा 40, 80 वगैरे आलाय?
48.
हा सर 40-80 आला.
40-80.
40. अजून कुणाचा काय वेगळा? अजून वेगळा कुणाचा काय आला? तुम्ही खूप छोटा ग्राफ काढला ना तर तुम्हाला एक्झॅक्ट पॉईंट मिळणं थोडं कठीण आहे या केसमध्ये. थोडा स्केल मोठं घ्यायला पाहिजे. ठीक आहे, तर व्यवस्थित येईल. पण ठीक आहे, तुम्ही ग्राफ पेपर यूज करताय त्यामुळे तुमचं करेक्ट आन्सर असणार आहे. ठीक आहे, 4179 असेल तरी यू यूज दॅट अँड फाइंड आउट झेड व्हॅल्यू. ज्यांचा 4080 आला त्यांनी 4080 वापरून करा.
सर 40-80 यूज करून Z ची व्हॅल्यू 3520.
3520. 3520 and R चा दी कोऑर्डिनेट सांगा. 240.
240,0.
What is the value of Z?
9600.
9600. ठीक आहे, 4179 नी काय व्हॅल्यू होते?
3536.
3536. Okay, so it is close. No problem. Now tell me which Z is minimum. The first one, 3456.
Yes.
Yes.
Okay, so what is our solution? Our solution is x1 is equal to 0, x2 is equal to 144 and Z mean is equal to, always write Z mean Z max because that will give you the objective function. Z mean is equal to 3456. So this is our solution. Are you getting this? Are you getting this from this graph?
Yes, sir.
Okay, now take one more problem. You people try to solve this. Then we will solve it by both the methods. Extreme point enumeration, you solve it. Then I will tell you about isoprofit line. Then apply this isoprofit or isocost line to these two problems as well, which we have previously solved. Is it okay? Okay, so take down the problem. Maximize Z is equal to maximize. So let me take maximize Z is equal to 15x1 plus 10x2, 15x1 plus 10x2 subject to linear constraints of 4x1 plus 6x2 is less than or equal to 4x1 plus 6x2 less than or equal to 360. 360. Second constraint is 3x1 is less than or equal to 180. So plus 0x2 rather. Three x1 is less than or equal to 180. There is one more constraint. 5x2 is less than or equal to 200. And there is non-negativity condition. X1, x2 greater than or equal to 0. Can you solve this by using graph paper?
Yes, sir.
Solve it now. Yeah.
Sir, can I ask a doubt about the previous question?
Yeah, why not? मला
Sir,
सांग
what if we-
आपल्याला पिन किंवा अनपिन कसं करायचं आता हे केल्यानंतर मी ते व्हिडिओ दिसायचा बंद होतोय ना
सर नाही व्हिडिओ दिसते तुमचा
मगाशी दिसत होता का मग आता मी हे ओपन करतो वन नोट दिसतोय बाजूला
Yes, sir.
दुसऱ्या टॅब मध्ये आहे सर
काय दुसऱ्या टाइम
गुगल मीटच्या दुसऱ्या टॅब मध्ये दिसते आणि स्क्रीन पण दिसते तुमची
हा मग तो टॅब मध्ये मी दिसायच नसेल तर काय करायला पाहिजे इथं अनपिन करायला पाहिजे ना
ते आम्हाला सिलेक्ट करायला लागते
आता बघ बरं
आता स्क्रीन दिसते सर
फक्त स्क्रीन ना
हो सर
ठीक आहे आता विचार काय डाऊट होता तुझा
सर व्हॉट इफ वी गेट अ सोल्युशन विच इज इन फ्रॅक्शन हाऊ कॅन वी प्रोड्यूस अ प्रोडक्ट विच इज इन फ्रॅक्शन
No, you will not get it in fraction.
सर इन प्रॅक्टिकल केसेस
Which one? Value of x1 and x2 you are talking, no?
yes sir
Value of x1 and x2 you make it fractional, huh? You may
Yes,
get
sir, that-
fractional values of x1 and x2. Either you have to go for converting into integer value. For that again integer programming method can also be used. That is also included in your syllabus. We will use that. But fractional values may be acceptable. Sometimes, suppose it is asked that how many kg of A is selected, and if it is coming at 18.6 kg, why not that should be the answer?
yes sir
So fractional value acceptable, absolutely.
So, but when we have to produce some parts or a product, how can I produce fraction of a product?
Now in that case, you will get answer integer value.
So then we must round up the
Or you
figure.
are converting into two integer, nearest integer.
Okay, sir.
Nearest integer. Or there is one more. If at all additional constraint is given that all the decision variables are integer, then there is one more method, integer programming method, which we are going to discuss in module 2. Okay? That you have to apply.
Yes, sir. Okay, sir.
त्याला वेगवेगळ्या मेथड आहेत, त्यांनी आपण सोडवू शकतो. आता आपण फक्त ग्राफिकल मेथड वापरतोय आणि ग्राफिकल मेथडनी दोन व्हेरिएबल्सचाच प्रॉब्लेम सोडवता येतो, ओनली टू व्हेरिएबल्स प्रॉब्लेम, अँड फॉर दॅट वी आर अप्लाइंग दिस सोल्युशन. पुढच्या मेथड्स आपण अजून शिकणार आहोत.
Okay, sir.
ठीक आहे. एनी डाऊट इज देअर? नो. ओके. हॅव सॉल्व्ड इट. ओके. एनी डाऊट इज देअर? कोण तर काहीतरी विचारत होता, बोला.
सर ओपन इलेक्टिव्ह लेक्चर आहे आता 4:30 वाजता.
ठीक आहे, मग आपल्याला थांबावं लागेल. ओके. यू सी दिस सोल्युशन, वेदर दिस इज द सोल्युशन यू गॉट. असा ग्राफ आलाय
Yes,
का?
sir. Yes, sir.
सगळ्यांचा ग्राफ
Yes, sir.
ठीक आहे. सगळ्यांचा ग्राफ आला असेल तर असा ग्राफ आणि फिजिबल रिजन बघून ठेवा. पुढच्या लेक्चरला आपण डिस्कस करूया. उद्या तुमचा क्लास आहे की नाही माहित नाही, मी एक्स्ट्रा लेक्चर घ्यायचा विचार करतोय. मी ग्रुपवर मेसेज टाकतो, किंवा आज संध्याकाळी घेऊया का? ठीक आहे. उद्या मी सकाळी मेसेज टाकेन जर लेक्चर घेणार असेल तर. जर वर्किंग डे असेल तर आपलं रेग्युलर लेक्चर होईल, नसेल तर एक्स्ट्रा लेक्चर संबंधी मी उद्या ग्रुपवर मेसेज टाकतो. इज इट ओके?
Okay, sir.
ठीक आहे. विल स्टॉप हिअर.